Hello and welcome to my video, lesson 4.2, factors and multiples of GCF and LCM. So factors and multiples. When we're looking at just straight up numbers, so there's no algebra here. We do GCF with algebra and we do it with numbers. We're just doing numbers today. So what is the greatest common factor of the following numbers? So here we have 54 and 36. To do this question, we're going to put down the two numbers, 54 and 36. And what we're going to do, I'm just going to make it a little bit thinner. What we're going to do is make a prime factor tree of both. So you can come up with any two numbers that divide 54 evenly. So 6 and 9 work. Just don't use the number 1 because it's not a prime number. And then 2 and 3. And 3 and 3. Now we can look at 36 and I can come up with 6 and 6, which is 2 and 3, 2 and 3. Given those two prime factor trees, we're looking for the greatest common factor. So what we're going to use is anything that's common between both, we're going to circle. And we're only going to circle it until we've circled things that are common. We always do it in pairs, one in each. And what you can see here is 2 times 3 times 3 is our greatest common factor, which is 18. So 18 is our greatest common factor for the first question. So pause the video now, try it out for part B, and then press play when you're ready. All right, so we've got 42 here and 28 over here. So 42 is 6 and 7, I believe, and 2 and 3. 28 is 4 and 7, which is 2 and 2. So now we're going to circle the parts that are the same. And you can see there's a 2 times 7 that's the same, so 14 is our greatest common factor. All right, that is GCF with just numbers, and now let's look at least common multiple and see if we can do the same sort of thing. Now, it is going to also start with a prime factor tree, but what we circle ends up being different, or how we count it, how we multiply at the end ends up being different. So first of all, we can use 3 and 4, and we can just do very simply and just do skip counting. So 3, 6, 9, 12, 15, 18, 21, 24. Okay, we'll just stop there. Let's do 4s. 4, 8, 12, and you can see it already. 16, 20, and 24. And so you can see already, hopefully, that that the 12s are common, and actually that the 24s are common. But it's not just looking for any old common multiple, it's looking for the least common multiple. So it has to be the 12, not the 24. So not the 24 because it's not the least. Okay, so that's like an understanding of what it is. Now let's do a more complicated example actually, and then I'll let you try part B on your own. So let's just do. I think I already have. I was going to do 18 and 30. You want to do those two? Does that work? 18 and 16. Okay. Let's try those two. No, let's do 20 and 30. No. Okay, let's do 20 and 30. Even though skip counting could work very nicely. No, let's do a more ugly one. Let's do 18 and 30. Okay, I've decided. Okay, 18 and 30. Okay, so you could skip count and get your answer, but it's going to be kind of a pain and annoying to do that. So what we're going to do instead is do this other method, which I'm going to say is still prime factor tree method. So 18 is 2 and 9, 3 and 3, 30 is 3 and 10, 2 and 5. And so if you look here, what are we going to do in order to basically find the least common multiple? Well, what we're going to do is we're going to count up the number of each number. So there's 1, 2 here, so 1, 2, and 2 3s. Okay, over here there's 1, 2, 1, 3, and 1, 5. So what we're going to do is whichever one lines up, so these two line up with each other, these two line up with each other, and actually this also lines up with how many 5s in this other one? 0. So in this example here, we can see that those different things line up. So what we're going to do is we're going to pick the bigger of the two numbers. So you can see here that the bigger number is the 2 here. There's 2 3s. So that's what we're going to put as our final answer at the end, okay? And then if we look down at the 5s, there's 1 5 over here, which is bigger than 0. Now, if we have the same number on both sides, then it doesn't matter which side we pick. So let's just pick this side. Okay, I don't know how to explain this in a nice way, but normally I wouldn't write out the red step here, but you can kind of see what I'm talking about. And we can go 2 times 3 times 3 times 5, and so we get 6 times 15, which is 90. I'm just trying to do that in my head. So our least common multiple is 90 for 18 and 30. So it wouldn't have taken too long to skip count to that, but there are some examples that do get a little bit worse. So I recommend you pause the video now and see if you can get part B now. Alright, so at this step, we're going to do the same sort of thing. So 12 and 15, we're going to write down our prime factor tree, which is 3 and 4, 2 and 2, 3 and 5, and actually we have to stop there. Then we're going to write down any numbers that are the same. So if they're the same between both, then we just count it once, and then otherwise we count it twice, or we take whichever side is bigger. So just like this, which is actually very similar to our last one, but it's going to be 60. So our final answer here between 12 and 15 is 60. So again, possible to skip count, but sometimes it's really annoying to do so. Alright, here are 2 word problems to try based off the same idea. The same sort of word problems here. We're talking about what is the side length of the largest square and how many squares could be used. So if we're doing largest square, this gives us a hint that it's GCF, greatest common factor. So what we're going to do is we're trying to make a square, but we're tiling it with a rectangle like this. So our rectangles have to together make a square. So let's just talk about the GCF. So GCF between 21 and 35. Okay, so if we do this, we're going to get prime factor tree 3 and 7, 5 and 7. Okay, now because it's a GCF, what that means is we're going to use the 7. Oh, we're tiling inside. Sorry, I read that wrong. Side length of the largest square, that could tile inside a rectangle with this much. It doesn't say the word inside, but okay. So that means our GCF is 7, which means we think the squares will be 7 by 7. So let's go ahead and see if we can make a rectangle out of squares like this. So here's 3 together make how much? 21 on that side. And how many together are necessary to make the 35? 1, 2, 3, 4, 5 of them. So this rectangle that I've just created is tiled on this side 35, on this side 21, and how many squares are used? Well, every square is 7 by 7, right? And how many squares are used in total? Well, 5 times 3, so 15 squares of side length 7 feet. I was going to say centimeters. So this is our final answer. Okay, maybe you can pause the video now and try the second question. Alright, so this second question says smallest square. So this is LCM, least common multiple. So we're going to do the same sort of thing, 18 and 16. And we're going to find the least common multiple. So between 18 is 3 and 6, 2 and 3. 16 is 4 and 4, 2, 2, 2, and 2. Okay, now what we can do here is recognize that one of the 2's is going to be copied, or like we did before, we can see that there's 1, 2 over here, 2 3's over here, and then we're going to compare it to the right side. And the right side has 4 2's and 0 3's. So we take the bigger of the numbers, so 2 3's and 4 2's. So we go 2 times 2 times 2 times 2 times 3 times 3. So this is going to be a pretty big number. 16 times 9. 90 plus 54, 144? Okay. Yeah, that makes sense. 144. Okay, so that means we think the smallest square that can be created using those sides, those rectangles, is a square that is 144 on a side length. Okay, so if we have a rectangle that's 18 by 16, this rectangle that I've just drew is not super accurate, but I think hopefully you can get the rough impression. We're going to have a whole bunch of these together to get to 18 this way, right? How many would it take? Let me just do this in my calculator, as it's much faster than me doing it in my head. So it should take 8 down. So actually I'm just going to go like this. And also 9 across. So there should be a square, okay, with 9 across and 8 down. Okay, which means each of these is 18. Maybe I'll use a different color. Each of these is like 18 plus 18 plus 18 plus 18, right? All the way down. And each of the ones on the top are all 16 plus 16 plus 16 plus 16 all the way across. And that means overall, it's 144 width and 144 length, which is what we're asking for. And if you were to ask how many rectangles does it take to make this, which it doesn't ask in this case, so in this case the answer is just 144 centimeters is the side length. But if it asked how many rectangles would it take, well, you could just count them. Or we know that it's 8 by 9, it takes 72 rectangles. Okay, maybe you're wondering, how did I get the 8 and the 9? I just went 144 divided by 16 got me 9. 144 divided by 18 got me the 8, which is how many pieces you need to stack up to get the 144. All right, I hope this video helps you better understand factors and multiples, and good luck.